there's a function that you might recognize. It's one of the equations of motion that describes the displacement, S for displacement, not S for speed, S for displacement, and how that varies with the initial velocity, the time, the acceleration. Okay? How many variables in that function? 4. S, U, A, and T. Okay? We're interested in how does the displacement vary with the time. So if you think back to when we were talking about these functions and the independent and the dependent variables, how does displacement vary with time? So which is the independent variable? The one that we're going to be controlling. So time is the independent variable. So the dependent variable is displacement. So what goes on the x-axis? Time. So time is the independent variable and goes on the x-axis. So that's x. And the displacement goes on the y-axis because that's the one we're interested in. What do we do about u and a? They're constants. Okay, so if I want to plot that, I would put in this formula into autograph. Y equals u. I can leave the letter u in there. X, because my t is going to be x, plus a half a x squared. So I could type that into autograph and I would get in y equals ux plus a half, so well 1 over 2, a half, 0.5 is probably the easiest way to enter that, a x squared. Y equals ux plus a half a x squared. So I'm assigning y to the dependent variable, which is displacement, and x to the independent variable. Hit OK, and we get this quadratic. Okay, so this is a curve showing how displacement, so this is displacement, varies with x. So I can zoom out or zoom in on it, shift it around. If I'm only interested in what happens to the graph from this point onwards, which is common because time, this is time along the x-axis, so we're not really interested in negative times. So in an engineering environment, usually it's this quadrant here that we're interested in. So let's just bring it down here and zoom in on the x-axis so we can spread out this here and then shift it across. So now we've got the relationship between displacement, which is on the y-axis, and time, which is on the x-axis. So after 2 units of time, possibly seconds, it will have gone in displacement of that. However, we've not worried at the moment about the values for u and a. And that's what we've got to think about first of all. Okay? We've got to find out what u and a are before we can plot this function properly. Autographs plotted something for us, and that's because it by default it sets u and a as 1. So if I go to the constant controller here and look at the values for u and a, the constants are in here. So whatever letter I put in apart from x and y will appear in this constant controller, and I can change the values of them, set by default to 1. So at the moment this function is plotting displacement against time when u and a are 1, which might not be the case. So the first thing we have to do is to find out the values of u and a, and then we can plot the function. So there's 2 parts to this assignment you're going to be doing. The first part is to find the values of u and a, and the second part is to find is to plot the function and then get some sort of value from it.